but it means for everybody, you need to take off, click his video, and so that the slides will go, So click the video. It's showing Osagie and slides. So just click Osagie so that we can clearly see the board. For me now, yes, I can see. Okay, so I'm getting feedback from other people saying yes, they can see. Okay.
Yeah, so
okay, so it's good. You can go ahead.
So you have
HACCP.
Yes. You have HACCP. Before you start your HACCP, the first thing you need to do is for you to have your team. You understand? You need to have an HACCP team. And that's your HACCP team, because you're not going to do it alone. Your HACCP team must be what? Cross-functional. Cross-functional in the sense that there must be somebody from engineering, there must be somebody from quality, there must be somebody from production, there must be somebody from procurement, there must be somebody from sales. It has to be a cross-functional team, and there must be people that have work experience, not less than 2-3 years experience. They understand HACCP, they understand food safety, and they understand how the business works. So they must be educated, of course. You must also, of course, the minimum criteria, they must have their BSc or HND minimum criteria, because they must be seen as people who, and they must be trained. The HACCP team member must be well trained. They must be trained. And when you assemble these people, from different departments, you need to train them on HACCP. Then each of them must have a role. That means you must print a job description for them with respect to their role in HACCP. You understand? With respect to their role in HACCP. So you need to explain to them, okay, Gabriel's role will be maybe, let me just pick one example. Gabriel's role will be maybe, he will be in charge of food safety. He will be the food safety team leader. He will be in charge of corrective action. He will be in charge of HACCP communication. Maybe Emmanuel Okon will be in charge of, pest control, process monitoring, cleaning and sanitization, and all that. So these are their roles, in HACCP. So I'll go back. Then you also need to describe the food and its distribution. You need to describe the food. It's very, very important. The food, I'm going to tell you how you describe that food. For example, maybe we want to produce juice, for example. So you need to describe what that juice is. You understand? Does he have any allergy? You need to say it. You need to declare it. You understand? Then you also need to describe how that juice will be packed. Will the juice be packed in a Tetra pack of 150 ml or 120 ml? You understand? You also need to describe the storage condition of that juice. How that juice will be stored. Will it be stored in a cool and dry place? Will it be stored in a refrigerated condition and all that? You get? So these are how you describe that food. I'm going to give you an example anyway, by when we continue. Then you need to describe the intended use. Is it for, the intended use means, is it for consumption by human? Is it for children? Does the food have any vulnerability? You understand? Maybe does it have any allergy? So like maybe, so you need to describe that. Is it for children? Is it for adults? You understand? Then you need to develop a flow diagram. You see, that's why I define what a flow chart is. So you need to develop a flow diagram, which describe your process. And you must make sure that that flow diagram is actually correct. Because if you miss it at your flow diagram, it's going to mess up all your HACCP. Because if you miss a step that is supposed to be a CCP in your HACCP and you didn't include it in your flow diagram, for example, maybe you have a level detector, for example, or no, a magnet, for example, on your line, and you didn't include it as part of the process step, you know, during when you were drawing your flow diagram, you know that you'll miss that part of from this saying whether it is a CCP or maybe an OPRP. Then that is why you have to verify the flow diagram. So in verifying the flow diagram, you need to go from the start of your, you know, process and begin, you know, and begin to, you know, and begin to look at everything. Okay, dumping, it starts from dumping, it goes to filling, from filling, it goes to date coding, from date coding, it goes to, you know, packaging, not in that order, for example. Sure you get. So you need to verify that you did not miss any step. It's very, very important. So these are the 5 things you need to first do before you start your HACCP. We call them the 5 preliminary tasks. So if Abiodun is about to set up his own bakery, for example, you know, Abiodun will firstly, you know, carry out these 5 things first. You will first of all get 5 people or 6 people from different parts of his to form the team. Then they'll ask, okay, this bread we want to produce, let us describe it. Is semi-solid or is it liquid bread? If there is it will it be with chocolate and all that, you know? Then this bread is actually for diabetic patients. You know, there's some bread for diabetic patients, so you need to specify it. We're also going to pack it inside maybe nylon. What kind of nylon? You know, what size of bread are we going to do? Are we going to do solo bread? Are we going to do medium bread? Are we going to do a very large bread? You know, then you now draw a flow diagram of your bread production process. After drawing the flow diagram of your bread production process, then you verify it again. The team come together to verify by going to the start of the production up to the end, you know, of that production. So after doing that, then we now come to, you know, identify the 7th principle of hazard is you identify potential hazards and measures for their control. This is a very, very, you know, critical task that must be carried out. You identify potential hazards. And I said the hazards are what? Physical, chemical, biological hazards. Then he said, identify that potential hazard and measures for their control. It means that, yes, I've identified for each process step, you know, as you have documented in your flow chart. For example, if it is dumping, for example, I want this part to be interactive. So I might want to ask question and I need somebody to, respond. So I'll know that people are actually catching up. So, for example, let's pick a process step. For example, in your flow chart, dumping of sugar, for example. Now you want to dump sugar for the production of your beverage. Now you are the quality control manager and you are doing your HACCP study. You understand? And you want to identify what kind of hazard can happen, at the dumping section. Because in your flow chart, you identify that your dumping section is part of your, production flow. You understand? So you want to identify the hazards that is happening at the dumping section. So I want to ask somebody, what are the 3 hazards we can find at the dumping section? Or what are the types of hazards, firstly, we'll find at the dumping section? Can somebody tell me the answer?
Willing to bail us out of this question, please just either you raise up your hand or you can just put it in the chat box. I'll read it for. Yeah, raise up your hand. I will mute you. Then you put it in the chat box. So, but Osagie, I'm already seeing some answers. So, some people are they know book very well. Let me read it.
Yeah. So, what did they put? Miriam just raised her hand. Miriam and DBC, she just raised her hand.
Okay, Miriam.
So, what 3 hazards can we find at the dumping section?
So, Miriam, you can speak. I've asked you to unmute, so you can speak.
We can have
Okay. Okay. Okay, that is very, very good, Miriam. So Miriam has been able to tell us that at the dumping section for the production of our bottled drink, that we can have microbiological hazard, which is biological. Then we can have chemical hazard. We can also have physical hazard. So she has been able to identify the 3 potential hazards that can happen there. Now, the next thing now is that what physical hazards can you now
somebody
find
else
at dumping?
Osagie, will you want to take another person?
Okay, yes, let me take another person.
Yeah, because we have, there's no name. He's saying read me notes, notes 96. So I've asked you to unmute. You can unmute and speak. He was raising up his hand, so read me note. I don't know.
Okay.
Yeah.
This is Samuel, Enauru Samuel.
Okay.
Okay.
Like as she has rightly said, we can have microbial hazard, microbiological hazard. We can have chemical hazard, such like sand. We can have a chemical hazard. We can have physical hazard such as sand. We can have chemical hazard such as allergen and pesticide or heavy metals. Thank you.
Okay, so thanks so very much,
Okay,
so you see now that we are making progress now. We have been able to.
There's so much in the chat box. So.
I'm actually not seeing the chat box.
Matter.
I'm missing.
Oh yeah, but I can read it for you. So Okwe says foreign matter. Okoni Manuel says unclean sugar silo. Okwe also says things like sacks, like maybe the strings of the sacks.
Good.
Then we have physical hazard. Mayowa says biological hazards. Sack thread. Okwe says that. Vivian Osima says biological and physical hazard. Micro contamination of sugar by Kingsley.
Good.
So yeah, I think insects invading the sugar. That Shola Falade said that.
Good.
Debris from sugar container or bag. That's Kingsley also.
Good.
Olatone says physical rope, chemical smell from cleaning substance. Then dust from the room if the temperature is not controlled. That's also Kingsley. So yeah, so we had that loss. Threads, stones, and sand.
Okay.
So
that means so look at what we have done. For dumping section, we'll be able to say we have physical, chemical, and biological hazard. Now, what are now the physical hazards there that can happen? Now, we said physical hazards are extraneous material, that can inadvertently or that can unintentionally be introduced, into your semi-finished product, into the sugar tank, for example, because you are dumping sugar. So the physical hazard that can go there now is, number one, the hair from the dumper. You understand? Especially if the person is not using hair net. If the person is keeping hair like me, you understand? If he doesn't cover his hair with hair net, then the part of the hair can fall into it. So it's a physical hazard. Another physical hazard you can have there is the wool from the sugar bag can also fall into the sugar tank. So it's a physical hazard. You understand? So let us just take those 2 examples for physical hazard. Now, for biological hazard, the hazard that can happen there is, number one, introduction of salmonella. Because if your dumper goes to the toilet without washing his hand, the person can introduce salmonella into your finished product, into your sugar tank. You understand? Then chemical hazard can come in form of, improper sanitization of that tank. For example, you are doing CIP of that tank. Cleaning of that tank, maybe you use lye and acid to clean it, and it is not well cleaned. The chemicals are still there. Chemical residue are still there. So it could be a source of contamination. It could come from the pest chemicals you use, to control pests. That's pesticide. It can come from there. It can even come from your cleaning like the soap you use maybe to clean that particular area. You understand? You can mistakenly, soap can mistakenly fall into it. So these are it can happen. You understand? Then, so we've been able to identify the physical, chemical, and biological hazards that can happen in the dumping section. Now, the first line is saying identify potential hazard, which we have done. Then it now says measures for their control. So for each of these hazards that you have identified, that's the physical, chemical, and biological hazard, you have to put a measure for controlling them. So for the physical hazard now, how will you prevent, I'm going to ask you again, how will you prevent, like you're dumping sugar now inside a sugar tank? So how will you prevent the wool from the sugar bag from entering? How will you prevent, what physical hazard did I mention again? I'm getting old.
The wool
what else again?
So the wool
wool from the sugar bag.
From sugar.
Then even the hair from
your hair strands.
Yes. Then even the hair nets that the person is using, it can fall into it. We've seen cases in the hair, it can fall into it. So how will you prevent it now? So Elizabeth Adeyemo, tell me, how will you prevent the how will you control? What control will you put in place to ensure that those things don't fall into the tank?
Okay, so I'm seeing some responses. You say one says use of hair nets, proper hair nets. I like that word. Okon Emmanuel, thank you. He said proper hair nets. So use of sieves. That's this Ongo Africa. Someone says
a sieve.
Yes, a
very
sieve.
Important.
Yes.
Yeah,
filter.
very
Someone
important.
else says filter. iPhone to everyone.
Very important.
It says filter.
Yeah.
Let me see. You have a section where the wool can be removed before taken to dumping section. Okay,
Good.
that's what someone is saying.
Good.
Say strict adherence
Good.
to the use of SOPs. Someone else mentioned that. Sugar vessels should have a filter and proper gowning. Someone else says.
Yeah, so you can see that now that guys here are already starting to do the HACCP themselves.
I'm telling you.
So you see that it's not difficult to identify hazards. Then you've identified the hazard yourself. You have identified, which of the hazards can happen for those hazards that you have mentioned yourself. Now you're not talking about the measures. The measure is you are putting a sieve. You understand? Such that you can put a sieve, at the opening. Maybe this is maybe this is the tank. This paper, maybe it's the tank. Let me roll it like this. This is the tank. Can you see? This is the tank. So you put a sieve here.
Yeah.
So if I'm pouring sugar, if I'm pouring the sugar there, the sieve will hold the sugar strands strand from the sugar. Even caked sugar will not be able to go in. You understand? Then the dimension of that sieve is also important, because you already know, okay, what dimension will you need? Because if the sieve is if the mouth is too big, if it's too porous, the sugar strands from the bag can go into it. So you look at the dimension to be sure that only the size of that sugar can actually go in. Anything bigger than the size of that sugar will not be able to go in. So it's a physical control that you have put in place. Somebody mentioned that, maybe you have a place where you decrafting. Maybe you remove the sugar, but that's for a very, very complex process. But if your process is a direct process whereby you dump directly, you understand, then you have to put in this control. As simple as CVs. Then make sure that air net is provided at the point of dumping, so that if the person is dumping, it covers his or her head. So if the person is keeping beard like this, the person should use a beard cover. You understand? So these are the physical measures you are putting in place. Now, after putting up this measure, if you don't monitor this measure, is it not going to fail? Don't you think it's going to fail?
Yes, of course.
It's going to fail, right? So,
yeah.
So the measure is going to fail, but it's going to fail if you don't monitor. For example, I'll actually explain this later. For example, that's your sieve. You must be checking it to be sure that it's not broken. So you might put a program to say, we're going to be checking this sieve every maybe after dumping every 6,000 bags. We're going to be checking it based on how you have validated it, that this sieve, probability that it will go broken is maybe after 6,000 bags is dumped, or after 1 month. So that's the control, that's the monitoring you are putting now. You understand? To check on that control, which is the sieve that you put. So every 1 month, that's the frequency of check of that sieve. So you check it monthly. If it is bad, you replace. Then you might also put a daily control to say, okay, before I start dumping a batch, I check the sieve. Shikena, you're done for that particular physical hazard and the control you're putting in place and the monitoring. And who will be responsible? Who will be responsible for it is very important, because you have identified your hazard, you have classified your hazard, you have put in measures, you have put a monitoring system. But who will now monitor it? It's not Spirit now. It has to be Bernard. It has to be Okun Emmanuel. You understand? It has to be Dominic. It has to be Osagie. So you have to put my name there, that Osagie will be the one monitoring. Then, if I want to monitor, in quality, what is not documented is not done. So you have to put a record. You have to put a record at that dumping section where there will be an evidence that the person checked the sieve. So you put, is the sieve intact? Yes or no? Is it clean? Yes or no? Those examples like that for that sieve, you understand? Then the person signs. So it's an evidence that the control that you've put in place is being monitored by the document you show. Do you understand? So that is what HACCP is. This is what identifying, that's how to identify a hazard. Now, but something I missed out that I should have mentioned is the severity of that hazard. The severity of hazard. Now, let me tell you something. Risk. I'm also going to explain this much more later. Risk. Risk. I might say on the board, I don't know if you can see, is a function of the likelihood that something will happen multiplied by the severity. Risk is equal to likelihood that the hazard will happen multiplied by the severity. The severity means if it happens, what is the impact? Can it kill? Can it kill? Can it destroy the process? You understand? So that is the severity. If I slap you now, for example, now, see this is my hand. If I slap you now, it's different from, the severity won't be as much as if a soldier should slap you, or if a mechanic should slap you, because this hand is Biro is using. But if a mechanic that carries engine slaps you, it's going to be different. So the severity is the impact. Likelihood is, can it happen? So for example, now, if I'm going to ask Bernard, for example, that is it likely that somebody's hair will fall into that sugar tank? You will say, yes, it's likely. It's likely. But for the hair to fall, for somebody's hair to fall into food, maybe that person is actually sick, that his hair is now pulling off. You understand? So the severity, even if hair fall into your sugar tank, I can tell you that it can't kill. It can't kill. It can't kill. Sure, you understand? So you will note that when you are calculating your risk, the risk will be very, very low. So the likelihood that it will occur can be 1, you understand, or it can be 3, that it can happen. If it happen, then the severity, if air even fall into it, what will happen if I consume that food? The severity is low. So even if the likelihood is 3, if I multiply it by a low severity because it can't kill, which is 1, so 3 times 1, so you say your risk is 3. You understand? But if it is microbiological hazard, the micro hazard that we can see, the now I mentioned introduction of salmonella, that one can kill. If salmonella enters into your product, you understand, it can kill. You understand? And you don't have, and to make matters worse, you don't have, your process is not a heating process, it's a cold process. So maybe there's no point in your production process where you subject it to high temperature heating to destroy the salmonella, or the agent causing it. You understand? Then it can kill. So the likelihood that it will occur is 3. The severity that it can kill is like 4. So if I multiply 3 times 4, that's 12. You can see that it is more severe to have microbiological hazards present in your food. So you have to put up controls. So now let us do an example of the control we can put for microbiological hazard or salmonella from getting into your food. We've done the risk. The risk is 3 times 4, which is 12. The likelihood it will occur is very high because people go to toilets every time, which is 3 or 4. Then the severity, if salmonella enters your product and somebody consumes it, it can kill. You understand? They can even close down the company and close the business. So the severity, the impact can be 4 or 5. So 4 times 5 will give you 20. So that's critical risk. So the control that you will put in place for microbiological hazard is what? You have to put hand sanitizers at the entrance of your dumping section. You have to put, you have to ensure you have hand gloves worn by your dumpers. So if you are working in dumping section, you need to wear your hand glove. You understand? After wearing your hand glove, okay, you wear your hand glove so that you can't introduce it into it. Then you can create an hygiene junction before your dumping section, or maybe after your toilet, at the entrance of the toilet, you put hand sanitizers also there to ensure that the person can wash his hand with soap, water, and sanitize his hand before coming into the factory. So this is a control you need to put in place. You understand? And how do you monitor, this, Elizabeth? How do you monitor it? So what monitoring will you put now to, okay, so these are the controls that we have put in place now. Person went to toilet, and okay, Okwe want to say something. The person went to toilet, came back, he didn't wash his hand, and straight to your filling room. But you, as the one conducting the HACCP study, you have put in controls, and the controls is you have put in, hand washing stations, sanitizers, for them to use, and it is compulsory for you to wear hand gloves, at that section. So how do you monitor the control? So Okwe want to say something, or Dominic, do you have anybody putting answer in the chat?
Let me Okwe, you can speak now. You can unmute and speak. I've given a. Then after Okwe, then Gabriel wants to say something.
Okay. So I earlier dropped my question in the chat box before we proceed. The question is, the control measure, is it, sorry. Can you hear me? The likelihood of
yes, we can hear.
Is it going to be based on the control measure you have put in place, or without assuming the control measure to be there? Is that how you're going to classify it?
Okay, so like for when you're saying likelihood, that, so in probability, you say the probability that something will happen is 1 or 0.
Yeah, is it with the control measure in place or without it being in place?
Yeah, so because okay, so with the control measure in place, yes, you must put it, because your control measure can fail. It can fail also.
Okay. So Osagie, let me come in here. just to, because this is risk assessment part. So just to give a proper perspective, when you start your risk assessment, when you do your first, when you do your first likelihood, because it's an Excel sheet, you know it has that RPN. So when you do your first assessment, when you're doing that likelihood, you are doing it first without an action, that's without a control measure first. Then you get a score. Then you now do it again. When I now have this control measure, what will be my new risk score? You get, so it gives you a better, so maybe before without your control measure, you have an RP and a risk score of, let's say 11. I'm just using the score. At the time you now have a risk, you now have a control measure in place, you should show that your risk score should drop. You understand? You can drop from an 11 to a 6 or something. This is just at the top. I'm just using numbers. You get, so you should, I always advise that you have a risk assessment file that has that the before the control measure score and the after the control measure score, so that somebody sees the work you are putting into this. Okay, I don't know if that helps. We have I still have Osagie, do you want to take these questions now, or we should wait? Because I have Gabriel hands up, I have Femi.
Maybe let's get to hear what they're saying, what they want to say.
Okay, so Gabriel, I'm asking you to unmute. You can speak now.
Hello.
Yes.
Good afternoon.
Yeah, good afternoon. Yes, we can.
This is Gabriel Iboi. I just want to comment on what my boss has been saying before now, especially on how to monitor the control measure put in place in order to ensure that salmonella is being eliminated or is being prevented from entering the production floor or dumping floor, as the case may be. Like, the control measure has been put in place, but how do we measure it? We measure it by putting probably the CCTV camera in places like a toilet now. Someone that went to toilet, and we expect him that by the time he's coming out of the toilet, he should wash his hand and probably sanitize his hand very well. There is possibility of him rushing back to his duty post without doing those things. But once the camera is in place, that will definitely track whether he or she actually do or does what is expected to do before going back to his duty post, especially dumping floor, before he goes back to dump. And also, some of them, when they are going inside the toilet, there's possibility of someone out of hasting, he wanted to go in and come back. He may likely not pull off his PPE, especially the safety boot, before he enters the toilet and comes out. Though he has washed his bonbon and everything, he has to wash, even the hand, but the safety boot itself, how are we going to ensure that there is a particular control measure to take care of that? And that is where the issue of using aprons, the junction where you need to enter and probably clean with a kind of disinfectant or a form of sanitizing a sanitizer before he enters into his duty post. So that is one of the ways to monitor the control measure putting in place to ensure that a microbial organism, precisely salmonella, is being prevented from entering the dumping floor. I hope you heard me.
Okay, yeah. Clear. So,
thank
Claire,
you.
Gabriel. Okay, so Emmanuel, Osagie, I think.
Yeah, so I think we need to move forward. So, part of the control you put is your, annual food handlers test. It should be done. It should be part of the control you put in place. You need to do food handlers tests, and during this food handlers test, all these things are done to ascertain that those producing do not have typhoid and all that can introduce salmonella into products. So, and I don't want us to dwell much on this, because the reason why I'm actually nailing on this area is because it simplifies every other thing I'm going to say here. You've put in a control you know, you've put a monitoring system in place, you know, of course you have to put a corrective action to take when that your monitoring system is has failed. You understand? So let us move away from point one, which is the first point in the HACCP principle. Determine critical control points. So how do you determine critical control points? You determine critical control points using, you know, your decision tree. So your decision tree is a schematic diagram that tells you, you know, that gives you, that answers the question at every stage gate or at every point in your production flow. You understand? And help you determine where is critical and where is not critical. Before now, I said you should take note the difference between your operational prerequisite program and your CCP. I told you that the thin line between them is that for your CCP, failure at that point, there's no other control that can take care of it. But for OPRP, yes, it is critical, but there's no other control that can, there is a control that can take care of, you know, if there's a failure at that point. So you determine your critical control point. I'm going to show you how you determine it. Then establish critical limits. So critical limits is your spec, you know, what is acceptable from unacceptable. So establish critical limit that, okay, for the production of bread, the oven temperature must not exceed 20 degrees plus or minus 5. So 20 degrees plus or minus 5 is either is 25 degrees or 15 degrees or is 20 degrees. So at that point in time, you say you are within your critical limits. But anything below 15 or above 25, you know your bread can get burnt above 25. Below 25, below 15, it can be underbaked, which can cause spoilage after some few hours. So you need to establish your critical limit. So that's why you must have spec. That's why as a quality person, a process control technician, you go to the line, you are checking, oh, the temperature of this, okay, is within spec. This one is out of spec. Then establish a monitoring system. So the monitoring system is what we have been discussing since, you know, because you've known your hazard. So you need to put a system in place to monitor, to ensure that that hazard, it doesn't happen. And even if it happens, there's something to take care of it. Then establish the corrective action to be taken. Now I told you that correction treats symptom, but corrective action, you know, determine the cause. So you establish corrective action. So for each of your process step, you identify the potential hazard, you put measures for their control, you determine if it's a critical control point or not, you put critical limits at that point, then you also establish a monitoring system that will be mentioning, like maybe you put your magnet or you put your sieve, you understand? Then you put a corrective action. If that system fails, so if the system fails, what do? You understand? You need to put it in place. Then establish verification procedure to confirm that the HACCP system is working effectively. So this is going back to confirm that what you're monitoring that you have put in place so is actually working as planned. Then you document. And that's why I said you need to have record. For each of these controls, there must be an evidence of monitoring, which is you're writing that, oh, I check my oven temperature is at 20 degrees centigrade, you know, there must be a record. You know, I check my sieve weekly, or I wash the sieve, you know, hourly, you know, something like that. So that is how you implement HACCP. It is very, very simple if you know what you are doing. It can be very, very complex if you don't know what you are doing. So now, you know, what is an HACCP plan? What is an HACCP plan? Sometimes you go for interview, you know, you are going for a QA manager role and all that. you will definitely be asked. I don't see how you can escape it. Somebody asking you what's an HACCP plan. I remember when I was to do a promotion, interview to be a quality manager when I was in Coca-Cola. It was one of the questions I was asked, that what is an HACCP plan? So HACCP plan is a document you don't need to memorize. From what I've explained, use that 7 principle to explain the HACCP plan. That's all. So for the 7 principle, I told you the first thing you do is 1, you identify the hazard, and put measures in place. Secondly, you determine your critical control point. The third one is you establish your critical limits. You understand? Fourth one, you put monitoring for the hazards that you have identified. You understand? You put a monitoring system in place. Then you put corrective action in place when there's a failure. You understand? Then, of course, you also document. You understand? You also document. I told you before now that you're in your HACCP plan, or you need to put who is responsible for cleaning of the sieves. Who is responsible for that. You need to put the name. It's very, very important. Then also you document. So your HACCP plan is a document showing hazards that can happen, in your production process, the control for those hazards, the critical limit when exceeded, which when exceeded can cause harm, and also monitoring and corrective action put in place when for controls and when there's a deviation, respectively, as the case may be, with roles and responsibility assigned to who is responsible for the monitoring and eventual documentation of the same. You see, I've defined HACCP plan for you. So you're not going to see it in the slide. So that's how you should define your HACCP plan. So if you go for a QA manager interview and they ask you about HACCP plan, you must mention all these elements. So if I'm part of the panel, if you don't mention all these elements, I'll say, Mr. Man, you don't know what you're doing. You understand? So it's a document. So you see that there's always a table, a very big table. They call it HACCP plan. So it's a document that shows, you understand, the hazard, the food safety hazard that can occur. So it shows your process step, that is oven, that is dumping, sieving, drying, baking. You understand? It shows your process step. You understand? It shows the hazards that can happen for each process step. It shows the risk. You understand? Which is a function of severity and likelihood that hazard will occur. It shows the monitoring you will put in place. Sorry, the control measure you will put in place. And the control measure is what? You put a sieve. Simple as that. You understand? Then you establish a critical limit. You understand? Which is, don't use this sieve beyond 2 months, or change the sieve totally beyond 2 months. Sorry, once it's 2 months. You understand? Then you put the monitoring that you need to put in place. So that means, what's the frequency of checking it? Is it going to be monthly? Is it going to be weekly? Is it going to be biannually? Is it going to be yearly? Then you put corrective action. If there's a failure, what will I do? You understand? Then you also put who is responsible for what. Then you document all these things I've said now. You now document everything. That's all. So that's what your HACCP plan is. It's as simple as that. So this is all about what food safety and HACCP team members, what they do. This is what they do. They must have wide knowledge about food safety, understand the activities around verification and validation, participate in internal audits. They must be able to verify and validate your CCP. So validation and verification of your CCP can be done, biannually or annually, depending on what you people decide. Then, of course, they must give input to, management review. So you get, so this is what auditor will be requesting from you. You have your HACCP team. What department are they from? Are they from different departments? what is their role, you know, their qualification, their responsibility in your food safety management system or HACCP program. What is the responsibility of Abolanle? What is the responsibility of Oluwafemi? What is the responsibility of Elizabeth? You know, it will always, you must have a role to play, you understand, for each point in time. So, of course, this is part of what they do, which you can always read up during the slide. I don't want to waste much time. So these are the inputs to the meeting. This is what you discuss during your HACCP or food safety meeting. Then, so for your prerequisite program, I actually put something very, very important, that you need to list all your process. You understand? For your prerequisite program, you understand? Your prerequisite program, for example, water treatment process is a prerequisite program. Why? Because your water is actually a semi-finished product, which is going into your finished product. You understand? For the production floor, water is semi-finished. For the water treatment man, water is his own finished product. So is a water treatment process is a prerequisite program. If you want to produce Coke today now, you understand, you need to treat water. So if you don't put a system to treat the water, then what HACCP do you want to put on the production floor? Your HACCP won't work. Your HACCP won't work if there's no cleaning and sanitizing program. So you need to identify, you know, all your PROPs, the location where you can find them, the kind of analysis you do at that point, then you see the test carried out, the responsibility, who's responsible for it, then what is the expected outcome of your prerequisite program. For example, for pest control now, what is your expected outcome? What's your expected outcome? So it's what's effective fumigation. You understand? Effective fumigation. So this, you need to do a table like this to identify all your PROPs. So when you go back to work, you know, on a Monday, you understand, identify all the prerequisite program. There are basic conditions that must be met before you can start producing. Basic manufacturing conditions that must be in place. You understand? Your control of non-conforming products is also a prerequisite program. So even though you have a fantastic HACCP, you now generate a non-conforming product. If you don't manage it well, you understand, and that product escapes to the trade, then it becomes an issue. Then your HACCP, you say your HACCP has failed. So that is why your PROP is the foundation. Then I talked about products description the other time. You know, like Abolanle's bread, for example, Abolanle water. Abolanle water, Abolanle wants to produce water, and she decides to name it Abolanle Braimon's water. So ABW. Abolanle, you now have a water factory. So Abolanle wants to set up a water company, and she wants to do HACCP study. Part of the preliminary steps you must take is for her to describe their product. So for the product, you need to have a name for the product. You need to describe the category of the product. Is it alcoholic? Is it non-alcoholic? You know, is it a carbonated drink or not? Then you have to describe what packaging material will I use. You know, am I going to use transparent nylon? Am I going to use transparent bottled water? What will be the shape? Is it refillable? Is it non-refillable? You understand? Then what will be the pH of your water, of Abolanle water? You need to also tell us what microbes can you expect, you know, that your product is amenable to. For water, of course, water can have yeast and mold, you know, even E. coli, if it's not well treated, you know. Then your method of preservation, how will you preserve your water? What are you using to preserve? So, of course, for water, you use UV to sterilize your water, to kill microbes. You understand? Then you need to talk about the physical nature of your product. You understand? The physical state, is it solid or liquid? The appearance, is it clear or it has suspended material? Is it clear or not clear? Maybe it has color. Maybe the kind of, maybe you are doing a juice, for example. So the color is not going to be clear. So the color is going to be maybe orange color. You know, what is the taste? The taste, of course, water should be tasteless or insipid. You understand? The odor, it should be odorless. Color, it should be colorless. For bread, you say the color should be brown. You know, for the odor of bread, you understand? You know what to put there. Then composition, list of major ingredients. You know, the things you use. If it is bread, for example, you need to know what you put. You know, your yeast, your whatever, butter, sugar, whatever. Then what is the size of that your bread in terms of volume? Is it going to be solo bread? Is it going to be medium bread? Is it going to be family bread? Is it going to be king size bread? Then how will you present it in trade? Is it going to be on pallets? Is it going to be like just a loaf or combination of, you know, different loaf and all that? So this is what they're asking you. For the product description, you have to mention the final product characteristics, the chemical and biological characteristics, and also the packaging characteristics. So these are the first step. Because tomorrow you might be called, a new company might be coming up, and you might be called to come and consult for them on HACCP. So these are the things you need to do for them. You understand? Then you talk about the shelf life, you know, the storage condition. You know, I talked about intended use the other time. Then is your product amenable to potential abuse? For example, you know, codeine is amenable to potential abuse, so they will always write it there. But of course, bread is not amenable to potential abuse now. So you have to put it there. Is there any group vulnerable that so they are linked to, you know, to say if your product is for adults or is for children? So, but for in case of this example now is water, everybody drinks water. Water has no enemy. So safety information, is it safe across all population and age group? If it is, you write it there. Then other information like the labeling, you know, the label that you will use, you know, list of special features, you know, if it will have tamper evidence and all that. So these are the things you must document. I'm going to leave this slide with Dominic, so he's going to share with any one of you that is interested. So you can also read up, you know, so that you're on your way to becoming an HACCP consultant, and you'll be making side money. Just remember me in your paradise. Okay, so I've explained all this. You can see that that's why I'm not a fan. When Dominic was saying, oh, my slide is too short, just 30, I said, I don't really work with slide like that. I don't really work with slide. But if you see, hazard identification, I've told you how to identify. So you see that I don't need to talk much here again. I don't need to talk much here. I've told you how to identify your hazard. So just look at your flow chart. You know, your flow chart is part of the preliminary step. So you have dumping, you have oven drying, you have sieving and all that. So look at each of your process steps and write there which is physical, which is chemical, which is biological. You know, so this is what you have there. I don't need to speak much on hazard identification. Then hazard evaluation. The team assesses the severity of the health consequences. Now I've told you all this, and I've told you that the team also determines the likelihood of a potential hazard. You understand if it will happen or not. Then the HACCP team decide and list the hazards likely to occur. I've explained all this. So conduct risk assessment for each identified hazard, which I've explained to you. I explained to you on how to calculate risk, and I'm going to show you this table. Look at this table now. If something is unlikely to occur, that means that thing can take like almost 5 years before it can happen. So you give it 1. If it's something that can happen maybe every year, maybe once in a year, or occasionally, you give it 2. That it's likely to occur. If it is likely to occur every month, give it 3. If it's not likely to occur every day or weekly, give it 4. You can see how we do the likelihood. Now look at the impact. The impact is the severity. If it is minor, impact is 1. If it is medium, it's 2. If it is high, it is 3. If it is very high, it is 4. So now look at the definition of minor, medium, high, very high. For minor, there will be no significant impact. For medium, there will be limited impact. For high, which is 3, that will require medical intervention. You understand? But for 4, this one can kill. Understand? So the difference between 3 and 4 is that medical intervention can save, but 4, that one can lead to, it can kill. So if you see now, if I now say for dumping now, for example, Abiodun, are you listening? Yeah, Abiodun is listening. So if I now tell you now, for example of dumping now, from my definition of risk, I said risk is the product or is a function of likelihood that an event will occur and the impact. So risk is likelihood multiplied by the impact or severity. So is it likely that during dumping of sugar, that the wool from the sugar can fall into the sugar tank? Is it likely to occur? Abiodun?
Let me ask him to mute, right? So he can speak now. I've asked him to.
Yeah, hello, sir.
Hello?
Hello, can you hear me?
Yeah, I can hear you.
Yeah, it's likely it happens.
Okay, it's likely to happen. So what number are you going to give it? 3 or 4 or 1 or 2?
I'll give it 3.
Good, because it's likely to happen.
Sure.
It's likely to happen because you know where wool from the bag will always peel off. There's nothing you can do about it. It's likely it's going to happen, which is 3. So what about the impact? What will, if the wool, if it falls into the sugar tank, what is the impact? Is there a significant impact, or is it a limited impact? Will it require medical intervention? Will it cause health issue?
I'll say 1. I'll give it a 1, a minor impact.
Good. So you can give it 1, or you can give it 2. You understand?
Yeah, sure.
So it's minor impact. So, or limited impact. So if you multiply 3 by 2, it's going to give you 6.
6.
So, and I'm going to show you a table that will now tell you the risk category. You understand? Whether it's critical risk, whether it's minor risk, whether it's major risk. You understand? Or whether it's low risk. I'm going to show a table next. So these are the tools you work with when calculating your risk assessment. Because next series, which will be next week or as determined by Dominic, we are going to do a live case scenario of, you understand? Okay, we want to manufacture juice, and you are the quality manager, and you want to do HACCP study. So we're going to do HACCP study, a live case HACCP study. So, and you need all this knowledge because we're going to be using it then. Do you understand? So if you multiply it, you have 6. So we'll look at this table now. Look at this table now. Look at the likelihoods that something will occur. It's 1 to 4. You understand? The impact is minor, medium, high, or very high. So look at now, the 6 that you got, is it low risk? Does it fall under medium risk? Does it fall under high risk? Where does it fall? Hello, who answered me the other time? Hello?
I think it was Abiodun. Okay, but I can see Rajiv is saying is medium risk.
Good.
So I can just read from the chat.
Okay, good.
Okay, yeah. Chidima is saying it's medium risk.
Good, it's correct.
Yeah.
So it's correct. So you can see that it's medium risk. But for example, now if I go back, so if I
most people have Elizabeth is saying it's a medium risk.
Okay.
Medium risk. So
okay.
So where do we are? She's saying medium risk.
Okay. So let me go back now. Let me go back to this thing again now. Okay, look at for if salmonella.
Yeah. So
more likelihood of. Okay, most people pick medium risk, so the medium risk is actually the answer. So we want to do another example of a microbial possibility of microbial contamination, maybe salmonella, being introduced during dumping. So what is the likelihood that is going to happen, and what is the impact? Then what is the risk? Can somebody answer? Can somebody unmute and answer? Hello? Hello? Hello?
Okay, anyone can raise up their hand and we'll just pick them. I think Okon Emmanuel want to answer.
Yeah. So Okon Emmanuel,
okay, so
let's
you
go.
can
So
unmute and answer.
Yeah, Okon Emmanuel, let's go.
Okon Emmanuel wants to answer, so you can unmute and answer.
So Okon, go ahead. So what's the likelihood? You understand that?
We can hear you, Okon. You can go ahead.
Dominic, if it's not speaking, can we read from the chat if people are answering already? To calculate the risk, for salmonella introduction. Yeah. So for salmonella or microbial contamination in dumping, what is the likelihood that it will occur, and what is the severity? Then what is the risk rating?
Yeah, so Femi is saying it's a 2 for likelihood. Severity is 4, so he's putting the risk matrix at 8. Elizabeth says it's a 4 and 4, so that should be a 16. Okay, Ongo Africa is saying the same thing, is 16. Raj is saying the same thing, that is a 16. Okon Emmanuel said frequently. So Olayinka is saying it's a 2 by 4. So likelihood 2, severity 4. So that's at 8. Likelihood
which is
4,
also,
severity 4. That's a 16.
Yeah.
Okay, Emmanuel too is saying it's a 16. So Precious is saying it's a 16. Grace John is saying it's a 12. She's putting at a likelihood at 3 and severity at 4. So from what I see, is most people are saying the severity will be 4, and the likelihood is around a 2. 2, 3, 4. That's what I've seen so far.
So from the table of this table that I've shown you now, so how do we now classify the risk? So you see that the risk is high risk. So if you multiply and you got 8, 12, or 16, you see that the risk is very, very high. So it's a high risk.
Yeah. Yes, that's.
You understand? It's a high risk. So that means that is why you see that your food handler test, you must do it. It's compulsory. Everybody must do it. Provided you have something to do with production, you must do that test. Then you must make sure that there is sanitizer, hand sanitizer, or soap, before you enter your dumping section, and even your toilet. You must make sure that you have, all those things there, so that the people they can wash their hands. Then, on no condition, as a quality person, you now go there and you meet a dumper dumping a sugar bag without wearing his hand glove, using his bare hand. You have to send the person out of that place. So these are the controls, you have to put, in place. You understand, to mitigate against it. So you get So you can see that we can all calculate what risk is. We can actually say this hazard. This hazard, we can actually say it is medium risk, low risk, and it is high risk. We can actually give it a rating. That's called a risk rating. You understand? So you now understand how we do the calculation. So don't forget your risk is, severity that something will happen and the likelihood. So this is your decision tree. One very, very important chart that you will use in determining if a step is a prerequisite program, an operational prerequisite program, or it is a critical control point. So with what I've explained so far, if you have, let me paint a scenario. If you have, I don't want to, let me paint a scenario now. Okay, bottling operation. bottling operation. No, I'm going to, no, so listen to me attentively now. I'm going to say something. You have to interpret what I've said. Then you will tell me if it is a prerequisite program, if it's an operational prerequisite program, and if it's a critical control point. So Dominic is a quality manager that works with Dominic Nigeria Limited, authorized producer of Dominic drinks. In Dominic industry, one of the equipment that is used include the bottle washer, which is actually used for washing the bottle, and some common chemicals are actually used during the bottle washing process, which can either be caustic. Some controls are actually checked by the quality team, which includes, the spray jets, the alignment of the spray jets, the temperature, and pH of the chemicals dosed in the washer. Now, along the bottling line, there is an equipment called Iboi, All Surface Bottle Inspector. The task of that Iboi is to remove extraneous material present in the washed bottle. Extraneous material can include pin, it can include nylon, it can include glass fragments, it can include mold. This machine is capable of removing them. And this machine is placed before the filling machine. Now the filling machine, there is likelihood of bottle burst happening, at the filling section. So an intervalve guard is placed between one filling head and another to prevent spillage or bursting or a spillage of fragments into the finished product. The machine is also programmed to reject 8 bottles whenever there is a glass fragment, because of the potential that there might still be possible escape of fragments into the finished product. But after the filling machine, there is no longer a control that can check if you have extraneous material or glass fragments in that finished product until it goes to the warehouse. So that is the end of my tale or my story. So can you tell me now, using this decision tree and from the definition of the difference between OPRP and CCP, which one will you consider a prerequisite program? I mentioned 3 machines. I mentioned the bottle washer, I mentioned the Iboi, and I mentioned the filling machine. So which one will you consider as prerequisite program? Which one will you consider as critical control points? And which one will you consider as operational prerequisite program? So let's go. So who's going to answer? Fastest finger. What are you typing? What do you have in your chat?
Yeah, so I think you can type or just raise up your hand and I will pick you. But let me go through the chat.
Yeah.
Okay.
Because all this knowledge, very, very important when the next series, when I want to do a real case as HACCP study for a production line. Like you are being called, Abiodun, please, we want you to come as a consultant to come and help us implement HACCP. How will you be able to do it? So you need all this knowledge, because by next week, I may not be going to all this thing again. We'll just be moving very fast. You understand? So you need to be able to identify what the critical control points. Let me explain it. For critical control points, no other control. If hazard happens if there's a failure in your critical control point, there's no other control that can remove it. And failure at that point, if that product escape, can cause a full safety hazard or full safety issue. But for OPRP, it can also reduce or eliminate hazard, but there is a control that can still take care of that hazard, even though the OPRP fails. Now, prerequisite program. These are basic conditions that must be put in place before you can commence production or before you can say you want to start doing HACCP. So from what I've mentioned now, bottle washing.
Okay, so we have Vivian. Let me start with Vivian. Vivian is saying bottle washer is PRP, OPRP, filling machine, right? Or FBI, OPRP, and filling machine CCP. Bottle washer, that's this Ongo Africa. Bottle washer is PRP, EBI is OPRP, filling machine CCP. Femi is saying they're all parts of PRP. The bottle washing machine is a CCP, while the EBI is an OPRP. Avinash is saying filling machine is CCP, EPI is OPRP, bottle washer is PRP. Elizabeth is saying filling machine is CCP, EBI is OPRP, bottle washer is OPRP. Adewale is saying EPI is CCP, filling machine OPRP, bottle washer is PRP. Nathaniel says filling machine is CCP, bottle washer is OPRP. Okay, I don't know who this is. Okay, Uptid is bottle washing is PRP, bottle washing is also CCP. Not correct. So Okon Emmanuel is saying filling machine is CCP, bottle washer is PRP, and EBI is OPRP. So I see more people saying that filling machine is CCP, bottle washing is OPRP, and the EBI is still ranges between OPRP and OPRP more for the EBI. So you advise us. So it's the answers are scattered everywhere.
Okay, the answer is scattered everywhere, right? Okay, so a good one is a very, very good attempt. It shows that people are actually listening and will not have a problem when we want to do a live HACCP studies. So that means we'll not have any issue. So now, using the decision tree and the definition I've given to you now, you can see that bottle washing is one of the process steps. Now, your bottle washing, I will agree with you, is a prerequisite program, because these are just basic conditions that must be put in place before you can say you want to start, implementing your HACCP. Do you understand? Now, for prerequisite program, it is not really critical, because will a subsequent process step eliminate or reduce hazard to an acceptable level? You understand? You say no. You say yeah. If it is yes, it's prerequisite program. If it is no, it's OPRP. Now, if you now get to question 4, can the hazard be monitored by objective direct measuring parameters for controlling all the products? If it is yes, it's a CCP. If it is no, it's an OPRP. So your bottle washer, it is actually a prerequisite program. The EBI, I said that it removes extraneous matter. If your bottle is not properly washed, there's an EBI there that will knock it off. You understand? So the EBI knocks it off. So you cannot say your bottle washer is a critical control point because something is already in the line to knock it off. Now, very, very dicey. Very, very dicey between EBI and the filling machine. The filling machine, it is obvious, it's a critical control point, because if you don't have your intervalve guard, if there's a bottle burst, I said it that the product leaves there, it gets coded and it goes to the warehouse. So there's no other control if there's glass fragment inside your finished product. So your filling machine is actually a critical control point. But let us look at the EBI. There was what if your EBI fails and you have glass fragment inside of it, or you have a safety pin inside of it. Remember, your washing machine does not have your filling machine doesn't have the capability of detecting it. The filling machine is just like an imprecise. Anything that goes there, to just fill it. You understand? Your filling machine is not capable to sense that if the EBI, if it fails, if like maybe there's the washer did not wash the bottle very well, then you have, then you now have the glass fragment. You have glass fragments inside this water, and the EBI could not knock it off. Inside this bottle rather, and the EBI could not knock it off. Do you know that it will go into the filling machine? The filling machine will fill it and it will go. Do you know? So will you still say that the EBI is a prerequisite, is an OPRP or a CCP? let me tell you my experience. When I was in NBC that year, we actually made our EBI at a point. We made it prerequisite program. Later, we changed it to operational prerequisite program. You know, as your knowledge keeps increasing, you know, when you're getting more knowledge and all that, you begin to review. You begin to review that no, this is not. So we got to know that okay, what if this EBI? Hello. So if you look at it now, if it fails, so I would categorically say that the EBI is a CCP, while the filling machine is also a CCP. Because if the bottle washer fails, they don't wash the bottle well, what if the EBI fails? Do you have any control after the EBI? Because after the EBI, the bottle is going to the filling machine. So if there's a safety pin inside, the machine will fill it up with beverage. And if somebody consumes it, so imagine somebody drinking a pin, that can be injurious to the person. So the EBI is a critical control point, because failure at that point, after that point, there's no other control. If assuming you have maybe a detector after the filling machine that can detect fragments or can detect any other thing, then it changes your decision tree again. It changes it. So your EBI will just be it will be an OPRP. Even your filling machine, if there's something that can detect, you know, glass fragments after it, something that can still detect it and knock it off, then your filling machine will automatically become OPRP. So do we understand how we you know are able to place all these things? So you now know the difference between your critical control points, operational prerequisite program, and your prerequisite programs. So your bottle washing is a prerequisite program, pest control management is a prerequisite program, your cleaning and sanitization program is a prerequisite program, your waste management is a prerequisite program, your fleet management is a prerequisite program, your warehouse practice is a prerequisite program. You understand? You know, a lot of all these things, your personnel hygiene is a prerequisite program. They're all prerequisite programs. You understand? But the thin line between OPRP and CCP is that for OPRP, there's a control that will take care of it if there's a failure. But for CCP, no more control. Yeah. So my screen is no longer okay. So we've talked about all this, so I don't need to define all this again. So it's something you can just read up. So the monitoring system.
Yeah. So I think we need to get to the point where we can we'll be able to take questions from people.
I think we can take questions.
Yeah.
I think we can take questions because the slide is off. It's over.
So yeah, so we can send in our questions. Though there was a question I missed earlier. Someone asked if mycotoxin is a chemical or biological.
Mycotoxin.
Yeah, is a chemical or biological hazard. So I know I missed asking that question earlier.
So mycotoxin, they are secondary metabolites of fungi. You understand? They are secondary metabolites of fungi. These are mycotoxin. So it is a biological hazard. It's a biological hazard. So that is that.
Okay, great. So I guess I was able to answer that person's question before someone else me. I was able to ask that person question. Okay, so someone also asked earlier, I think I took notes, they wanted you to clarify, but I think this is already clarified. He was asking that we wanted clarity on OPRP and PRP, but I think over time, this was very early in the session, but I want to believe that is clear now. He wanted clarity on that, OPRP and PRP, but I want to believe that is clear now. Please confirm last decision step in decision tree. I think the no should go for the CCP. Okay, that's from Kingsley. So the decision tree, maybe you should project the decision tree again. He's asking that we should confirm that the last decision step in the decision tree, I think, is showing a no. that is saying, Kingsley, should I unmute you to speak? Let me unmute Kingsley so he clarifies his question. I'll look for Kingsley now.
So actually, okay, you want to speak?
Oh yeah, so just explain what he's trying to say. I'm looking for him to unmute also.
Okay, so I said one thing, when defining critical control points. Let me go back. When I define critical control point, look at it. Critical control points, and let us look at operational prerequisite program. Let's look at the definition. So PRP identified by the hazard analysis as essential in order to control the likelihood of introducing food safety hazard to and or the contamination or proliferation of food safety hazard in the product or in the processing environment. But for food critical control point, he said, is a step at which control can be applied and is essential to prevent or eliminate a food safety hazard or reduce it to an acceptable level. Now, that's why I explained it earlier on. I said for critical control points, you call it a critical control point because it is a failure at that point can cause hazard. So for critical control point, it must control all the hazard almost absolutely. Do you understand? Critical control point, it must control all the hazard absolutely. So for example, glass fragment at the filling section, glass fragment at the filling points. You understand? Your glass fragment at the filling points, if there are no intervalve guard, there will be spillage of glass fragments into your product. So that's why you must put your glass fragments, you must put in fact, your filling machine should never run when you don't have your intervalve guard in place. That is the control put there. So the intervalve guard should be able to prevent spillage of a glass fragment into another filling head. You understand? By at least 99.8%, almost, if not 100%. So that is why you see that once there's a failure, we shut down the line. We shut it down. No intervalve guard, no run. Like the machine will not run. Do you understand? The machine will not run at all. Do you understand? But for operational prerequisites, it can totally eliminate it, yes. But if it does not, it is not a problem. Something will take care of it. So that is why you call it an OPRP. There's something in front that will take care of it. Do you understand? So that is the thin line between critical control points and OPRP. You understand? For critical control points, the control there is absolute. But for OPRP, it can either be absolute or not absolute. But not to worry, there's something waiting to take care of it. So, and that is why, if you look at the definition, if you look at the decision tree, you see that.
Yeah. So, someone is saying you should explain that decision tree very well. But before that, let me just read. And immediately I finish speaking, Kingsley can talk before you continue, because there's a point here which I like, is from Raj. Raj is saying that if it's a low risk, then there's no need for controls. Are we agreeing to this? That if it's a low risk, then why do you need to put a control? So that's one of his points. His second point is, if the likelihood is very low, but the impact is extremely high, then in spite of a low numerical risk of 4, consequences would be fatal. But what are your thoughts here? I can't hear you anymore, Osagie. Did I mute you? So sorry. I think you can unmute. I think I'm mistaken.
Okay, so for what Raj have said, based on my experience and from what I have read, for every risk identified in your process step, whether it is low, whether it is medium, whether it is high, you must put control. So, but the controls you put in place also can be as simple as just a net. You know, a net can act as a filter. You understand? To remove maybe caked sugar. So you must put once you have identified it as a risk. So yes, it may not have the potential to kill, but it doesn't speak well that your product should have a sugar bag, the strands from the sugar bag inside your finished product in the trade. It's going to come as a consumer complaint. So if you don't put a risk, if you don't put a control, even though you say yes, it is low, that maybe the strand from the sugar enters, if the thing escape and enter and goes to the trade, you know, your consumer is not going to look at you that by the time NAFDAC or regulatory agency, they come to your company, they say, show me your HACCP plan, show me your dumping section. Is this thing included in your risk assessment? Okay, you included it. So why didn't you put a control? So what would you say? Oh, because it is low? No. So for every risk you identify, you must put a control. Thank you.
So I also like the way Vivian put it here. He said if there's no control for a low risk, it can result to a higher risk.
Exactly.
Yeah. So yeah.
Exactly.
So please let's allow
accumulation of low risk will become medium risk, which in turn can become high risk.
Yes,
so that's
exactly. Yeah. So Kingsley, please, you can speak now. I know we've heard you so much on your. I think he was trying to say, he wanted to say something. Yeah. Is he still there?
Hear me?
Okay, yeah, we can, but you are going off and on.
Is it better now?
Oh yes, better, way better. Yeah.
All right, thanks. Thanks, Osagie. I really appreciate the presentation and very, very detailed. Really, maybe I will just collect your phone number, Seth. But that said, just to clarify, the clarification I need is the part where you also explained that one way to differentiate between a CCP and an OPRP is that for an OPRP, you have another control behind, which most likely is a CCP. But for a CCP, you don't have any further control. So looking at the question 3, it says, can the hazard be monitored by objective, direct measurable parameters? Can it be monitored? If you say yes, can be monitored, then the control is there. So it's, and you're saying it's a CCP. Going by the word where you say, if you don't have any further control, that is when it is a CCP. So please help clarify that. Maybe I'm the one mixing things up, but just by those two explanations, if you have a CCP, if you have an OPRP, it means you have a CCP behind it. Well, where you are getting to a CCP, there's no other control. So, and the question is saying there are measurable controls at this stage. And you say yes, and if you say yes, it means it's a CCP. So it's a bit conflicting for me. Okay,
so let me explain that for the fact that you have a control after an OPRP doesn't mean that control has to be a CCP. So it depends on the complexity of your process. You know, for a dairy industry, for example, the process is very, very complex compared to maybe a bottling company. When I work with Coca-Cola, that is a straight process. You understand? You can have several OPRPs in your production line. It does not necessarily mean that if you term this one an OPRP and maybe there's a failure, that something else that detects it, then that thing, if that thing detects it, then it's a CCP. No, we are looking at the severity. We're looking at the severity. Can this thing kill? Can this thing cause litigation? Can it cause an embarrassment to the business? So you look at the severity. So if you're going to rate the severity, you know, for OPRP and critical control point, you're going to be placing critical control point on critical, or you call it critical or major risk. You understand? Because failure at that point, it can kill. I always use that definition. It can kill, it can cause litigation, it can cause a full safety hazard. For example, like this glass fragment I talk about. You understand? If there's glass fragment you know, in your finished product. If somebody drinks it, that can kill. Do you understand? It can kill. But if there is maybe nylon inside your Coca-Cola bottle, finished product, it may not necessarily kill you. It may just require medical attention. Check what we. Sorry, I want to move. Let me move this. Look at what we did here. Likelihood that something we are called the impact description. We are saying high is medical intervention needed, but for very high health issues with possible fatal consequences. So you would always want to place your critical control point, on 3 and 4. Do you understand? So what I'm trying to explain here is that you can see the color here that the critical control point is colored red because you know what red signifies. That point there, the risk there must be totally be controlled by that CCP. It must totally be controlled by it. I work in dairy, so I don't want to mention anything related to dairy so that it won't be conflict of interest. You understand? So I may just choose. I'm just trying to choose a simpler process. You understand? A very, very simple process. There are some times whereby when you do a heat treatment of your product, for example, and you don't heat it well, when that product gets to the trade, it can go bad, and when consumed, it can kill. It can kill. Especially, I don't want to mention some things. Maybe like you have glass fragment, for example, and you now drink products containing, that can kill. It can cause litigation. It can close down your company. People might not want to drink it again, that for the fear that somebody died because there's glass fragments. So they may not want to risk their life. You understand? But for OPRP, there is always it can absolutely take away all the issue, all the hazard, or you can actually reduce it to a minimal level, but there's a control after that can take care of it. You understand? So those are the that's the thin line between OPRP and CCP. So if you look at the let me put it back to screen. Let me put it back to. Sorry, can you see my screen?
Yeah.
Yeah. Sorry, it just suddenly. Okay, let me put in PowerPoint mode. So, sorry, hold on. So if you look at it now, can the hazard be monitored by objective, direct, measurable parameter for controlling all the products? You can see that thin line for controlling all. Of course, your OPRP may not necessarily control all. So that's the thin line, may not necessarily control all. But your CCP must control all, because if it fails, no more control. So I think that is just the thin line. You see, this concept of HACCP is something that, I told you that there was when I was in Coca-Cola, the Iboi, it was a prerequisite program. Later on, when knowledge started coming in, we changed it from prerequisite program, we changed it to OPRP. When I left Coca-Cola, I learned now that it has been changed to CCP. So because when you keep on probing, you will see that those things that you call OPRP may be CCP. Those things that you call CCP may move down to OPRP. So it depends on the complexity of your process and the severity of hazard that can occur at that particular point in time. I'm so sorry I cannot use many examples, and I cannot use where the complexity of where I am right now, but for where I've left, which is Coca-Cola, that's why I'm using it. It's a much straightforward process, and that's why I'm using the issue of glass fragment. We can also check, there's some products that are amenable to microbial contamination if you don't process them well. So imagine somebody drinking it. You understand? Or maybe somebody having salmonella, and you are producing food meant for children. You are producing food meant for children, and the thing is contaminated with salmonella. You understand? Do you know that it can kill? So that's why I see that sometimes when you are producing food for children, you must make sure that your hygiene level is almost at 100%. If not, you. So I think maybe Kingsley, maybe we will maybe not to beat too much time. Maybe when we exchange numbers, we would trash it further.
That's another brainiac we'll meet. So okay, I went off for some time, but to be honest, I've missed my chat cleared, so I don't have most of the questions again. But I think we've also almost gone beyond our 2 hours time that was scheduled. So if there's, maybe we can take one more question. If you just raise up your hand, because I don't have it in the chat box again. I'm so sorry about that. So what I would, the presentation will share to everybody who has registered. So it means I have your email in the Excel sheet link. So I share 2 links. One, some people said it wasn't working, so I will still share to those who it worked for. The other link, which I shared later on, you can still register on that one. That's a fresh link. So I will share to both links where people registered. Okay, so that's one. So there's a plan to do a more, because I was pushing Osagie that, man, we need a more practical, like, let us do like a juice or a bread making. Let's do one session that has an example, like a more practical section. So we'll look at it. Hopefully I will share within the week if we'll do it next week Saturday, depending on Osagie's availability. So that will be a very more practical section. People can have their laptops and Excel sheets, right? So that we can fill in and complete like a complete HACCP plan and just do a complete one. And at least everybody will be able to do it on their own from then. My first experience with HACCP was not a very fantastic one. I must confess. I think I just joined the level then, and 2-3 weeks or a month into the job, we're told to go and do HACCP. I was like, HACCP. Of course, I would have had the name before I joined them, but never done anyone before. So it was, I learned it the hard way. So it's important for you to, so the aim of all of this session is just to bridge the knowledge gap so that nobody has to struggle to perform super well on their roles. So before you get into that new role where you need to do something, you already know what to do. When you get into the role, you know what to do and you do better. You can always improve in the things that we have shared today. So I can't see any hands raised. Okay, I can see Miriam.
There's a question. Okay.
So maybe if you can still see the question.
There's a question.
Yes.
So somebody said, does HACCP end at the manufacturing and packaging? Are there controls measures that need to be put in place when products are under distribution? So anything you do, with the one that that is outside the facility, you call them prerequisite programs. Like, I told you warehousing, how you stack your products, where you keep your products, the storage condition and all that, they are all prerequisite program. You understand? If you conduct, maybe you sensitize your distributors that, in your warehouse, you have to do pest control, you have to stack this product no more than 3 pallets, at a time. They're all prerequisite program to help, solidify your HACCP plan. Because even though you produce very well, and if you begin to have post-production issue, which is your products not handled well by the distributor, your consumer will still complain that you didn't produce it well. Maybe the product fell off, fell to the ground, and before you know it, the integrity is compromised. Then a consumer buys it. It comes as a complaint. So all those ones are prerequisite programs. So you can actually extend prerequisite program, beyond the facility and not HACCP. Thanks. So I think that's the one I can see from here.
Oh yes. So
Dominic, I can't hear you again.
I was on mute.
Okay,
I guess I was talking to myself. Okay, so I think I saw this. Yes.
So I saw a question now. Is 2 or more steps
raising up a hand?
Okay. I saw a question, is 2 or more steps of CCP
Okay.
or OPRP necessary in the production line for different kind of hazard? Yes, it depends on the complexity of your process. If your process is a simple one, you might just get maybe 1 or 2 CCP. While if your process is a very, very complex one, you can have more than 5, 6, 7, or even 8 CCPs. So the lesser the CCP, the better for you. But the more the CCP, then it's showing to you that you have more complex process. So like a bottled water company now, or a bread water company now, those ones won't have much CCPs. But if you take it to a much more big company like breweries where they produce alcohol, you will have more CCPs. You understand? Or maybe a dairy company, you have more CCPs. So it is relative, depending on the size of your operation. Thank you. So can the person now start speaking?
Yeah, so I think it was, I don't know if she still wants to say anything. It was BC.
She's still raising her hand.
Oh, okay, but okay, yes. Okay, I've asked you to unmute so you can speak. Oh, sorry, maybe not that phone. Okay, so 1 minute, I'll ask you to unmute now. Okay, so I've asked you to unmute so you can speak. Yeah.
Thanks so much for the training and but I would like to know if you can share with us the ISO manual, whereby we can also go through the courses and then look at how we can learn more from it.
Yeah, there's no problem. I can always share the ISO, the latest version, 2018. I can always share with Dominic, and he will share with every one of you.
Yeah, of course, yes. But for me, I have the one for 2020.
Okay.
5.
Yeah.
But for the HACCP training, HACCP itself, that's
the one?
The HACCP training itself, the HACCP.
Okay.
So I think for that, this slide will work, right?
Yeah, the slide. We are sharing this slide. Dominic will share the slide. So Dominic, another question for register so you can get their email. So yeah. Get the slide?
Yes, sir. Yes,
okay, perfect. Yeah,
okay.
I think Bernard wants to ask a question.
Bernard. Okay, so yeah, so the link is on the last post that I made on LinkedIn. Maybe when I share a post tomorrow, I will put the link again just to register. So latest Monday, Tuesday, everyone will have the slide. For those who want the ISO, the food safety ISO, they would also get that. Okay. So yes, I've asked you to unmute. You can speak, and I think that's the last. We'll take that person as the last person for this session, and we can call it a close. I will share the link for next week's session.
Hello, sir.
Yes, please.
Okay. Mr. Osagie. Can you hear me, sir?
Yeah, I can hear you.
We talked about the CCP being the last point of control. And you also said lastly that you can have more than
no.
More than.
Let me correct something here. Your CCP may not necessarily, okay, depending on where you place them. You understand? Depending on where you place them, it may not necessarily be that. Hey. Oh, someone is making. Okay, ask your question first.
Okay,
ask your question.
Take for example now, in a system, in a place where I work, we have when we're bottling our wines, we have a pasteurizer. who helps in doing our pasteurization process. Can you hear me, sir? Then after
Okay,
the pasteurization process,
okay,
during the course of bottling, there is a preservative that needs to be added.
okay,
A very strong preservative that is added to the wine before
okay,
it is now being called the finished product. Well, over
okay,
time, when that preservative, when there's a loss, or let's say when we fail to dose a certain gram of that preservative to the
yeah,
wines after pasteurization, we tend to experience spoilage after a given period, let's say 3-4 months, when originally it's supposed to last for 15 months, 15 months. Some takes 2 years. So now there is a pasteurizer and there is a preservative, a very strong preservative. I just don't want to mention the name of the preservative that is being added.
yeah,
So I know pasteurization to be a CCP because it has a limit, because we have it automated. If it doesn't exceed, don't get to the right temperature and time, it will not go to the next phase of production.
yeah,
It will go to the next phase. But like I said earlier, we have gotten over time, we've gotten to a point that when there is no preservative at that point where of the dosing of the preservative to the wine, we tend to experience spoilage.
okay,
So now you now make mention of CCP being the last point of control, the step in the process where a control is being applied to limit a significant food safety hazard to an acceptable level. But now I'm having another one that is taking or doing the job fully, doing the complete job of the pasteurizer, because the pasteurizer is supposed to also do that. So are we not saying that at the end of a CCP, there should be an OPRP?
So it does not necessarily mean that your pasteurizer must be a CCP. It does not necessarily mean your pasteurizer might not necessarily be a CCP. If you pasteurize and you already know the type of microbes that is common with your product, and you know that your pasteurizer should be able to reduce to an acceptable level the microbial load of that your product, and that addition of a preservative is what seals everything. You understand? It's what controls it absolutely. Then yes, your pasteurizer will be an OPRP, while that preservative addition will be your critical control point. So if that equipment that doses the preservative fails, then you have a problem. So for the fact that pasteurizer is a big name, because most of us, we always get carried away, pasteurizer is a big machine and all that. It may not actually be your critical control point, because you have your preservative that will take care of failures from the pasteurizer. You understand? Because your pasteurizer may not necessarily kill all the microbes. It might be that is the preservative that will now make the remaining one that escape the pasteurizer inactive.
Okay, because most of the challenge we had are always from yeast.
Yeah.
So that's why the preservative.
Exactly. So that means if assuming you have a sterilizer, the sterilizer will kill both everything that the pasteurizer could not do, and even some thermophilic spores. So, but because you don't have that machine, what you have is after your pasteurization is your preservative. Then your preservative, that part of it is the CCP. Then your pasteurizer is your OPRP. Shikena.
Okay. So Idoi made a comment here. Let me just read it out. I think it's an interesting one. She's also saying similar. She said the preservative preserves the product. Pasteurization doesn't destroy all microorganisms.
Exactly. So So that is just it.
As to what you were saying. Okay, so so many comments for you, Osagie. Like people are thanking. So many thanks to you for making it very detailed.
Thanks to God. Thanks to God.
Yeah. Somebody saying, "Oh, I can't believe that I did not pay money to get this kind of knowledge." God has paid you. Okay, so to be honest, we really appreciate you. I, number one, appreciate you. Don't worry, I'm on my way to your house now. I just need to wear a trouser.
Yes, a stone throw to my house. So.
I really want to use this opportunity to thank everyone for joining. I think it's also very important that we thank people for joining. So yeah, we could as well want to hold a session like this, and it would just be the both of us and maybe a few people. But if we could have close to 60 people here today, I think it's enough to appreciate everyone who joined. Hopefully, we have the practical section in the next one, and we'll break it down because Taufik will break down the process of CCP into processes that are OPRP to. Okay, is it possible to break down a process that is CCP into processes that are OPRP to reduce the hazard involved? So I think also what we can do, please, I will put, when I send the post tomorrow, I'll put my email also. So please, let's send in the questions that we have to the email so that I'll prepare it down for the next session. I think that would make sense so that we can have maybe answer all the possible questions before we start the practical section next week.
Yeah.
So that works.
So which one are we choosing? Very important. Is it bakery? Is it pure bottled water? Or is it juice? Which one are we doing as HACCP on? We have to just pick one.
I can do a poll. Poll on
LinkedIn. Exactly. Yeah. Okay, better.
I'll do a poll. I will do a poll on LinkedIn. Okay. What section we want to even
okay. Chidima said juice.
So yeah, I got do a poll, and we'll just
poll is fine. Yeah.
Next session. So I've also got my email. Just questions to that email, and we'll take it up from there. So yeah, thank you very much. Thank you, Osagie. Thank you all for joining. We'll be so glad to see you in the next session. So thank you all. Let's just leave our feedbacks.
Okay.
Leave your feedbacks in the comment section for Osagie. I think that's good. Yeah, so thank you very much. I really, really appreciate it. So let's have a great day. See you guys next week. Thanks so much to Tawali. I've kept him on the call for this is over 2 hours. And I doubt he even knows what are these people even talking about here. He's the one who gave us Zoom account.
Wow, nice.
What are these guys? What are these guys talking about? Thank you so very much. I'll call him now after the. So thank you all for all those who reached out and said, oh, they'll be joining, and they did. So thank you guys. Have a great day. I will sign out of my 2 accounts. Thanks to Paula, who gave me our phone as my second account. If not, it would have been terrible. Okay, guys. Yeah.
Yeah, safe. Yeah, bye. Yeah. Bye.